Hi everyone. It's a couple of years old now, but I still get emails every now and then about my Segway. Basically for anything from how I constructed the base plate, through the electronics, through the software, what IMU I'm using, that sort of thing. So I thought I'd do a short video here just to maybe explain a little bit more about it. Back flashing, contact jerking it out. Feel it. Didn't have that backlash, it's so much better for this.
You should try and fix it then.
These different motors and gearboxes. Okay, here it is, and I think the first thing you'll notice about it is actually quite wide compared to a lot of the other homemade Segways that are, you know, floating around the net. Especially with the pretty large tyres and wheels that I've got on it. I bought them off of eBay. I think they're basically a mini quad bike wheels that are on it. The DC motors are from a Jazzy wheelchair. They're 24 volt and there's a couple of lead acid batteries as you can see under there. Which power it. They're mounted underneath to keep the centre of gravity low. That's kind of the idea I had at the time. Seems to work out okay, but the ground clearance, you know, is pretty minimal really. There's only about, I don't know, 3 inches, something like that, between the bottom of the batteries and the ground. But it doesn't really touch, so it's not too bad. So the frame itself, it's a mild steel box section frame that I welded together, and then I've put like 3mm aluminium plate across the whole thing. But by using box section, what it means is that it's pretty easy to mount the foot switch, because, you know, there's a recess underneath, and anything else that's mounted on it is pretty easy to box in. You know, in fact the batteries, you know, they sit inside the recess as well. So the original wheels that I had on it are the ones that came from the original wheelchair. This is them here, and they're fine for on the you know, the pavement or the road, that sort of thing. But the whole idea behind my Segway was to use it off road. Up in the forest trails and that sort of thing. A lot of other people have actually mounted these motors vertically, but I just found it a lot easier. The mounting holes on the motor are along the base there, so it was far easier, and I thought just to lay them down would have meant extra bracketry to mount them, you know, up vertically. And of course they do extend over the back, but you know, they don't touch at all. They don't touch the ground. You can go right back on it, and they don't really hit at all. the steering mechanism was something I played around with, you know, quite a lot. As you can see, it's actually quite a beefy bracket that I've got there. And if I just swing it back and forward, you'll see it move. The original one that I had was it was far too lightweight, and you know it was easily bent and broken. So this was like the third attempt at, and you really do need something substantial because you are actually hauling on it, you know, from time to time. So basically, it's an L bracket, and there's a gap between the two plates here, and it's a nice interference fit of the vertical arm here. You know, there's no play at all, and it's actually greased up inside there. That makes it very, very, very smooth when you move it back and forward. So I've got a couple of screws there either end just to limit the travel of it, and of course the springs to make it auto return to centre, which kind of works. But of course the business end of the steering is a potentiometer, which is used to send the signal back into the electronics here. So again, I played with it a few different ways. I actually originally had a pot with a long shaft that went right through the steering mechanism there, but you know, the only shafts I could find were aluminium, so it kept on breaking them. So then what I did was I've just used a bolt through it, and I've kind of made my own little universal joint here, which kind of stops any force being applied too heavily onto the actual potentiometer itself. So with that in place, it's actually very, very reliable now. It doesn't look very good, but it is actually pretty reliable. As you can see it here, moving back and forward. There. You don't get too much movement in the shaft of the potentiometer, so you're getting nothing like the full range movement in the pot. But you know, I figured as long as I was getting a few hundred millivolts change back to the electronics, then that was enough, and as it turns out, it's not too bad. So following up from here, you can see there's another cable here that's been shrink wrapped. That goes up right the way up here onto the control panel. You know, right from the outset, I wanted to have an LCD that I could use to display, you know, certain parameters, that sort of thing. So basically, what I've got here is a run-stop switch. That works in conjunction with the foot switch on the base plate that they activate with my foot. You know, safety is critical. You know, one of these things starts going across your back garden full whack, you'll know about it. You know what I mean? It'll crash through fences, all sorts. So basically, safety first. So with the foot switch and the run-stop switch, I've got, you know, quite a lot of safety built in there. I've got 3 pots here for adjusting the PID settings in the software. You know, this is an experimental Segway, so it took quite a lot of work on the software to get the PID nailed, and even with that, it's still, you know, every time you go out in it, you're always finding you're tweaking some of the settings. But that probably comes down to my software. I'm not exactly a software engineer, so I've kind of hacked it together, but it does work. One of the other main items here is the balance zero. With different people standing on the Segway, they're going to stand slightly different, you know, either leaning a bit further forward than somebody else or leaning further back. So with this balance zero pot, it gives me the chance to adjust the center zero, you know, so that basically you're standing, you know, upright and without moving forward or backwards. You know, a nice easy zero position. So that allows me to adjust that. Okay, down into the electronics, I've lifted the cover there. Basically, you've got a Sabertooth 2x60 amp motor control board there, and there's the interface to the Arduino there. So you've basically got a speed control and you've got a direction control, and that's obviously coming direct from the outputs from the Arduino. And on the other side of the board here, here's all the heavy duty connections to the motors. There's a relay here. No, it doesn't look like a relay, but it's a hermetically sealed relay there. High ampage. I think it's about 100 amp, that one. Basically, it activates when you operate the foot switch here. And again, it's another safety thing. So with this activated, then you're enabling the batteries through the relay. Lift your foot and you're totally disconnecting the batteries, so that's a safety thing there. Then we've got the Arduino Nano down here, and the Gadget Gangster IMU accelerometer gyro on there. And of course I've got a few LEDs, a buzzer, and some decoupling there for and a 5V regulator, that sort of thing. One other safety feature I didn't mention, I've actually got a fuse, a large 50 amp fuse in series with the batteries as well, so your 24 volts is coming up from below up into here before it comes up into the main box here and onto the relay. So again, it's just another safety thing, probably more for transportation. It means I can lift the fuse, and there's no chance of standing on the switch and activating the Segway at all. So one of the batteries is a bit flat, but let's power it up and see if it still works. I've lifted the whole thing off of the ground, so the wheels are actually free to rotate, so I should be able to rock it back and forward and play with the steering and get the wheels turning. Okay, so first things first, we'll put in the fuse. Okay, I'll demo it from this side as well so you can see the control panel, but for the moment, if you just be head on there, I'll show you it working. So the fuse is in, so now I'll put my foot on the foot switch, and we should get power into the main unit, and the Segway should boot up. So what you're getting there is a tone. That's the Arduino looking for the center position. That's a safety feature as well. We don't want the Segway to power up when, say, the control arm, the steering column, is on the ground. Otherwise, it's just going to go full speed ahead. So I've got a safety feature in so that when you power up, the motors are not activated until the user has this upright, the steering column upright, and then looks for the center position. So that's basically what I did there. The beeping disappeared. That means it found the center position. So right now I should be able to push forward on the column, push back and steer, and the motor should, the motor should react accordingly. Once I put it in run position, of course. So there we are. We're in run mode on the control panel. That's it. So now if I either flip the switch into the stop position or indeed lift my foot off the foot switch there, it'll all come to a stop. That's it. Power's gone. Okay, here we are looking at the control panel. I don't know how easy this is going to be to demo, because it's obviously going to move around as I move back and forward from side to side, but hopefully we'll be able to see something. So what I'm going to do is I'm going to put my foot in the foot switch, the Arduino will start up, and you'll see please wait on the LCD. Then you should see it actually attain its balance point straight away, because it's more or less saved, and I'm more or less vertical anyway, so it should just go straight into run mode. So here we go. I've got this switch here in the stop position, but obviously that doesn't stop me from powering up. So here we go. So you can see there that we've got please wait as it was looking for the balance point, which it attained pretty quickly there. So again, we're in the stop position, so the motors are actually disabled at the moment, but we're ready to go. On the LCD here, I've just got some diagnostic information. I've basically got the PID information and the balance point information on the screen. That was basically just put on there so that when I could vary the pots here, I could see the optimum settings for the PID. So we've also got the balance light there, so that's on at the moment. So let me just go into run mode now. So we're all ready to go. I've got the run LED, I've got the balance point. So basically, if I start tilting forward, you can't see it, but the motors are actually going, the wheels are going round. And if I pull it back, you can see that the LED comes on. So the point where the LED's coming off and on, that's the balance point. So obviously I can pull it back. You can hear the motors there. Obviously I can move them side to side as well, so for the steering. The way I've got the software set up, the balance zero pot is actually disabled when we're actually running. That was to stop, you know, somebody catching their hand on here and you know, upsetting the balance zero whilst you were running. So basically, to adjust the balance zero pot, you have to go into stop mode, tweak it a little bit, and then go back to run mode again. So it's a case of playing back and forward to get the balance zero set correctly. And then obviously once you've found the correct balance point, you can then hit the save button to save it permanently. Then you never need to worry about it. So one thing about the wheels, I had to actually build up a boss to adapt the wheels to the shaft of the motors. This bush here is part of the original wheel, and as you can see, I've had to put some pretty large pillars in there and a big aluminium boss to give me the depth to, you know, to mount the wheel without it actually interfering with the tyre there on the motor casing. So that was just you know, a big block of aluminium there. And round the other side you can see how I actually also had to drill a hole right through the aluminium bush so that I could actually you know, remove the nut to take the wheel off of the gearbox shaft. So you can also see how I managed to bolt on the motors to the box section. I designed it so that there was 2 strips of box section here that lined up with the holes in the actual motor itself, the gearbox itself. So there's 1, 2, 3, 4, 5 bolts there. So here's a look at the underside. You can see the big heavy straps holding on the lead acid batteries to the underside, and you can also see the underside of the foot switch I've got there. It's a pretty hefty foot switch. You can't use anything lightweight. It's got to be pretty strong. So it's just something I had lying around there. I don't know where it's from. And that's of course the underside of the steering mechanism there. It's all bolted on with M5 bolts. And here's the other side showing the battery terminals. As you can see, the batteries are in series, so there's some quite heavy wire there connecting them together. There is actually a wire coming off. Basically, this is the 0 volts terminal, and at the far end there is the 24 volts terminal. But I actually need 12 volts to power the Arduino, etc. I didn't really want to take 24 volts and regulate it down to 5 volts. It's just a waste of power there, and I'd have to have a bigger heatsink. So taking a 12 volt tap seems to be the best way to go about it, and that works quite fine. So if I was going to change anything, it would probably be the motors and the gearboxes. These are just wheelchair motors and gearboxes, so they're probably not precision enough. It's one thing I have noticed. You get a little bit of backlash in the gearbox. You know, you can move the wheel and you can feel it moving back and forward, as it, you know, without actually rotating the motor. It's just taking up some movement in the mechanism, the gearing inside the gearbox there, and what that ends up doing is it's kind of limited me from getting the gain high enough in the software, because if I put the gain any higher than what it is at the moment, what happens is, you know, the motor, the software tells the motor to react to try and stabilize the Segway, so the motor starts turning, but because of the, you know, this free play in the gearbox, the wheel won't actually start turning, so you're still unbalanced. The gyro and accelerometer still detect that you're unbalanced. So what ends up happening there is the software tries harder to you know, to try and stabilize the whole Segway, and it gets to such a point where all of a sudden the free play is taken up, and then the wheel will react, but it's usually by that time it's probably too late. So like I said, ideally I would have a motor and gearbox with absolutely no free play whatsoever. I can't show you it now because I've got the Segway in the deck, but basically you know, you can move the wheel backwards and forwards slightly there, and you can feel it. You can feel the gearbox, you know, the free play in the gearbox there.